At Humboldt University, we see how embodied artificial intelligence, computer vision and active vision have been used to create feedbacks between an environment and the robotic tools in motion.
Our big goal is to understand intelligence and to understand the principles of intelligence in natural systems like humans and other animals, and to extract these principles and put them into algorithms and test them in robots. We think that not everything can be pre-programmed into the robot, but the robot has to learn and make experiences by the interaction with the real world. Show that here, so the robot is like a child, randomly moving its arm around and at the same time learning the correlation between the motor commands here and the position of the hand, as the robot can see by its own camera. That approach is called Embodied Artificial Intelligence. This adaptive approach is very much important for the ROMI project, where we're partners in, because we can't program everything just by hand, because the conditions change. You don't know how the area looks like, maybe even the robot hardware changes, motor changes. And so we can use our adaptive methods and apply them to the ROMI robots so they can really interact with the plants and extract information from the plants.
We have a system that implements a sort of artificial curiosity. The artificial curiosity drives the movement of the robot towards interesting locations. For instance, one of our tasks is to support the 3D reconstruction of plants. And instead of using predefined movements of the 3D scanner around the plants, our system instead is trying to make more intelligent movements to discover parts of the object that perhaps are more interesting to look at. So we have the learning system running at the moment. So we have the artificial curiosity based exploration that sends motor commands, and at the same time so all the information that are recorded from the robot, which are images which you can see here, and the positions of the robot are sent to the model which is going to be trained. So you probably have a goal that is like look at the tripod, like put the tripod at the center of the image. So that's probably one of the goals. And the idea is then the next step will be like to move around this goal. So as soon as your system is well trained, so this goal could be changing, for instance, because the plant is growing, so you need to move these goals around to make the system adaptive. It's coming back again to the tripod.
In ROMI, it's a very challenging task because we have to cope with these real systems, and we have to cope with wind and with weather and the plants growing unexpectedly, and so it's very challenging, but it's also very fascinating.
So the next step will be to, by having more movement capabilities, so you will be able to segment out parts of the images that you don't need. Antonio is actually working on segmenting out the interesting objects from the scene.
Okay.
And in particular also to avoid the arm to crash into plants. So you take first a screenshot from a camera that is located at the top of the robot, and then so you segment out all the objects that you don't need, and the object also where the robot could crash. So your trajectories will be going around plants to not crash onto them.